Right, 2020 mock exam paper, question 10. The elevation plan of a house built in the 1980s are shown. The owners intend to carry out a deep retrofit upgrade of the house to meet the NFIT passive house standard. Discuss two advantages of retrofitting an existing house to meet the NFIT passive house standard. Okay, well, two advantages, obviously. If we're going to go passive house, what are the advantages of my passive house? Well, I have all these here. I have the reduced heating costs, I have the improved energy efficiency of the building, reduced carbon emissions, increased savings on the overall cost of running of the home, improved well-being and quality of life for the inhabitants, reusing existing buildings in the community, and contributing to your moral responsibility to the natural environment and future generations. So it's reducing the heat, it's improving the efficiency, it's reducing the carbon emissions, it's more an eco-friendly home, so it's more sustainable over a longer period of time. Okay, so any two of those there, and it says discuss two advantages, so that's just a discussion there. Part B of the question then asks us to, using notes and freehand sketches, show the design detailing necessary to achieve the NFIT passive house standard of each of the following areas: external wall, windows and glazing, and air tightness. So here we need to do three design details. So we got three design details. We need a note and a sketch for each of them, and they're both worth 5 marks each. Okay, so I'm going to do out one here for you now, and then do out one here, and then we'll see about the other two. I said I can do them out again afterwards if you require, but I don't think there's much of a need to. As I said, most of these are just going back to the design detail and the sketches. So if we look here now, that's the first one, the external wall. Okay, so what are we doing to upgrade the external wall? Well, we have our, by looks, just looking at the plan here, it's a solid block wall. So we have our solid block wall there. How are we going to upgrade that? Well, obviously we're going to put insulation on the outside of it here. And that's our big one. Then we have a big massive wall anchor tie here that's anchoring that into the wall. And we got our plastering slabs. So we're talking high level of insulation. There's no thermal bridges. No thermal bridges. What else? That's our two big ones for the walls. Just a high level insulation and no thermal bridging, and that's all you can really do to the external wall. If we look, then I'm just going to do it. That's the external wall. We'll look then at the windows and glazing. Okay. So we'll talk about, does it tell us on our drawing where south facing is? It doesn't. What do we have to do for the windows? Well, we have to improve the passive house standard. So we need to bring the U value of the windows up to 0.8 watts per meter squared degrees Kelvin. So that's our big one for the windows. So even I'm going to draw my house here. I'm going to label it north, south, west, and east. So I'm going to reduce window sizes on the north and increase them on the south. Okay, so smaller windows on north facade. Larger on the south. Yeah, so I was just saying there, before I got cut off, larger windows to the south. Want the U value lower than 0.8 watts per meter squared Kelvin. Triple glazed. High insulated frame. So that basically means is in our frame here, we could draw a little sketch here for your frame. There's high insulation inside this. Yeah, so sorry about that. You know, triple insulation or insulated window frame with triple glazing. Okay. Low emission, so soft coat on panes which reduces solar radiation back out through the glass. The frame must be well insulated and thermally broken. Windows may be outward opening to maximize room space. Increase the window area in the kitchen and dining room. Designed to prevent overheating the sun with blinds, brise soleil, overhangs, deciduous trees to the south which allow sun enter in the winter but prevent the high sun entering in the summer. And so on. So that'd be for your windows and glazings. If your external wall, there's not much more you can do there. Maybe you could talk about how you put the window, how a windowsill would fit in there, say. So you have your windowsill there and you'd have a new insulated slab going down over that there and to extend out. But yeah, there's not much more you could do there. Your window glazing you can obviously talk a little bit more about. Then the last one then is air tightness. I'm sure we'll do this one out now as well. So you have your so you'll be talking about putting in your air tightness layer. So in the walls, our air tightness layer is our plaster. So that's our insulation going in there. That's our plaster, and you maybe talk about at junctions there where you could sketch out say the window head here. I'm going to do the window head for argument's sake. You know, and you put in your air tightness tape here. And this is how my plaster is airtight. Airtight, and then your air tightness tape seals joints. Air tightness tape seals joints. Would also put in that you have your, you know, just to highlight the fact that you want your whole house airtight. So that's my internal one there. Just kind of blue line on the inside. We have a continuous airtight layer. On the internal of the house. Okay, air tightness prevents the leakage of air from the internal environment. It also prevents infiltration of cold air. Plastering internally is sufficient air tightness. Issues can arise due to the penetration of mechanical and electrical surfaces. The inclusion of a surface cavity inside the plastered air tightness layer can improve the effectiveness of the air tightness layer. An airtight building must be properly ventilated to ensure adequate levels of fresh air. House it so it needs to be properly ventilated. Through the MHRV. To achieve the N4 passive house standard, the levels of air tightness should be tested with a blower door test. So with the blower door test. And this demands air tightness of 0.10 air changes per hour and a space heat demand of 25 kilowatt hours per meter squared per year. Okay, so that's kind of that part of the question done. And just big one is those numbers there and just your air tightness and your plastering and stuff like that. Part C of the question then, using notes and freehand sketches, discuss the importance of any two of the following in passive house design: thermal bridging, indoor air quality, and solar shading. Now I might get out the mark scheme here somewhere and just have a look at these ones. Yeah, so again, this is all the sketching that we've done so far. So thermal bridging. I spoke about thermal bridging. It's preventing the solid materials preventing, say, concrete touching off internally and externally touching without insulation between them, so allows cold air to pass straight through there. So a thermal or cold bridge is an area of a building that has a higher conductivity than surrounding materials. Significant detrimental rate of heat transfer from the surrounding materials, resulting in a significant reduction in thermal insulation. Performance of the building, thermal energy flows from a higher to a lower temperature. Flow increases with greater temperature difference, so the warmer it is in the inside, the more flow will increase out. Materials that are more efficient conductors of heat and penetrate the outer envelope lead to greater thermal energy transfer, increased heat loss overall. Local areas of greater energy flow provide cold spots on the inner surfaces and troublesome condensation, including interstitial condensation. More of a risk where passive house standard is achieved. Greater risk surrounding openings and where floors and ceilings are out the walls. Continuity of thermal insulation of great importance. So it's important that there's continuity, so there's a continuous layer the whole way around of thermal insulation. Passive house design attempts to eliminate all thermal cold bridges and includes this as one of its 7 principles. Thermal/cold bridging reduces the building's energy efficiency, which increases the energy cost per annum. Cold bridging reduces the thermal comfort of the building for its occupants. The presence of thermal bridging locations in a building's external envelope significantly increases the energy costs for the occupants in attempting to maintain thermal comfort. The presence of thermal/cold bridging in residential buildings can adversely affect the health and well-being of the occupants. The presence of thermal cold bridging can lead to hazardous mold growth, which may Also lead to deterioration of the building's fabric. Where thermal bridging is present in a building, a significantly higher proportion of heat energy passes through the bridge in an external envelope to the outside. Where the temperature is lower, this differential heat loss creates colder and warmer surfaces within the building on the internal surface of the external wall and may lead to condensation and mold growth. Those damp locations encourage growth of mold, which can be harmful to the occupant's health and can also contribute to the deterioration of the building. Where significant heat loss through the presence of thermal bridging, cold bridges exists and thermal comfort needs to be maintained, there will be greater energy demand. Where the increased energy demand is maintained using fossil fuels, then the building is not sustainable and increases the release of CO2 and SO2, which are harmful to the environment. All openings for windows and doors, junction between the external wall and the floor, junction between the external wall and the ceiling, the eaves detail, window sill, window and door head details, together with projecting balconies details, are typically locations where thermal bridges cold are formed in poor house design. Okay, so there's a hell of a lot of information inside there, but a lot of that's just repeated. So it's just about preventing damp and increasing the efficiency of it. But they've just labelled over it numerous times. So there's loads of points there, here and here in the mark scheme. So if you can hit 3 or 4 of them, that's what they're looking for in these questions. They're looking for maybe 2 or 3 of these points, maybe 4 of these points for each one, and a bit of a sketch. So see here where we have the cold bridging, we've got concrete touching concrete down the foundation here. So you'd draw out your sketch where you'd have concrete touching concrete and how you'd prevent that. Same here with the window, how the window sill would sit on the 2 inside walls, or maybe there's a concrete slab behind the 2 of them. That's where we need to prevent that. So how do? We put in insulation in between them. And same up above in the roof. Okay, so it's all about having insulation, not allowing materials to touch. Indoor air quality. Most of life is spent indoors. Indoor air quality and the healthy indoor environment are most important. Space, warmth, light and air are all affected the internal environment of a dwelling. Thermal comfort is the expression of satisfaction with the surroundings, too hot, too cold, or just right. Thermal comfort also influenced by humidity, drafts, temperature of surrounding surfaces, each individual's metabolic rate, clothing. Increased levels of air tightness required careful design of ventilation systems to ensure a continuous supply of clean, warm, filtered fresh air. Properly designed ventilation systems limit humidity and prevent mold growth and the buildup of pollutants through extraction. In a passive house, this is achieved with a mechanical heat recovery with ventilation, so an MHRV system. Ducted and ductless systems now available. MHRV unit provides the whole house ventilation and a regular controlled supply of fresh, clean air to all rooms. Warm, moist air, extract air is mechanically extracted from kitchen, utility, bathrooms and toilets. Outdoor air passes through a fine filter in the heat exchange unit to ensure dust, pollen and other contaminants are removed from the air. Thus ensures clean, fresh air to all the house. In the MHRV unit, the extract air and the outdoor air do not mix. Instead, they pass through a heat exchange unit. This unit is made up of a number of very thin metal or plastic plates. The heat in the extract air heats one side of each plate. The outdoor air passes on the other side of the plate and absorbs this heat energy. The outdoor air is now warm and filtered and is now called supply air. The supply air is pumped to living spaces, supply zones. The MHRV system designed to provide minimum air temperatures of 16.5 degrees Celsius when outdoor temperatures is minus 10 degrees. During cold weather, a post heater is used to raise the temperature of incoming air to ensure a constant comfortable temperature of 20 degrees Celsius is maintained in home at all times. During warm weather, a summer bypass is used to bypass the heat exchanger so the supply air does not cause overheating. MHRV designed for a maximum of 0.6 air changes per hour. Here. Insulated ducting prevents condensation and mold growth in the ducts. Windows can be opened in the summer for fresh air and to cool the house if overheating. Passive house design is to have an indoor temperature of 20 degrees Celsius throughout the year. Filters in MHRV should be cleaned every 3 to 6 months to ensure air is properly cleaned. Relative humidity of the indoor air should be in the range of 30% to 60%. Within this range, the benefits of water vapor in the air are optimized. Air not too dry or too moist. Keep all areas clean and dry and get rid of excess water or moisture. Filtered air prevents the growth of mold, dust mites, viruses and bacteria, reducing respiratory illnesses. Internal CO2 levels ideally less than 1,000 parts per million. To prevent condensation and mold growth, temperature of internal surfaces, e.g. walls, ceilings, windows, shall not fall below 12.6 degrees Celsius. Having fuel burning appliances inspected regularly by professionals for leaks and make repairs when necessary. Install carbon monoxide alarms and test for radon gas. Houseplants such as spider plant, chlorophyll, Chlorophytum cosmos absorb some airborne contaminants, particularly violate organic compounds such as benzyl, tuzol, and xylem, and reduce indoor air pollution. Plants remove CO2 and release oxygen and water, although the quantitative impact of the house plants on the indoor air quality is relatively small. Okay, now there's a lot inside there, a hell of a lot inside there. What I'd be kind of doing for air quality is I'd be going back here and I'd be talking about my MHRV unit. And that's your big one there. Just explain what the MHRV is, how does it work. It takes the stale air out of your bathroom, your kitchen, your utilities, and it pumps fresh air into your supply zones like your sit rooms and your bedrooms. How does it work? We'll be talking about it here. So it's designed to, so during the cold weather, the post heater is used. So it takes the cold air out, it transfers through the heat exchanger, and it takes the fresh air coming in and heats the fresh air coming in. I'll be talking about using my post heater here and the summer bypass. And I'd talk maybe a bit about maintenance and servicing of utilities inside there. Okay, but I wouldn't go into too much. I wouldn't be going down into, we don't need to go into this exact level of detail, but I think probably the big one is draw out your MHRV. So sketch your MHRV with two ducts and them coming out. Explain that you have the supply air and the extract air. So sorry, supply air is coming in set. Extract air is going out. Talk about the heat exchanger inside here. So how the extract air goes in, the heat is taken out of it and put into the supply air coming in, and then it's passed around the house, and that's what I'd be kind of doing for that one. Solar shading then is the last one here. So this is talking about brise-soleil to prevent overheating and things like that. So passive house demands largely on a solar gain for much of its space heating requirements. This typically requires large areas of glazing on the southern facade of the building. In the summer or during periods of prolonged sunshine, this can lead to overheating the building unless solar shading is provided. Solar shading can be designed as an integral part of the building structure, such as an overhang of the roof or brise-soleil. Such systems are based on the principle that in the summer the sun is at a much steeper angle than in the winter sun. A correctly designed overhang or brise-soleil will significantly reduce the solar gain during the summer period while having little impact on the solar gain during the winter period. Okay, so it lets all the sun in the winter, doesn't let in all of it in the summertime. Dynamic glass, which is standard float glass with an electrochromic coating applied on one of the surfaces, automatically adjusts its tint in the response to solar irradiation, does control the level of solar gain to the building. So it's like putting a tint on the outside of the windows that gets brighter and darker depending on how much sun is shining on it. And mechanical external shading such as adjustable brise-soleil, external roller blinds, awnings and sliding screens can be adjusted to use to control solar gain. However, mainly the system will impact on the level of natural light entering the building. Okay, so if we're cutting out sunlight, we're going to prevent light getting in. So we then can sketch out an overhang possibly here and a brise-soleil of some sort, or maybe some trees. So yeah, that is that full question done. That is that mock paper then more or less covered. What I'm going to get you to do is, if you have any questions or any topic, or you want me to go back over and explain a little bit more, or how to answer something a little bit more, put it in the comments underneath and then I can go back over it. It's a lot easier for me to basically go down through when you're telling me what you actually need, rather than me just going down through everything and covering the same stuff over and over that you already have. Okay?